Homework number 7. First two topics, single-step literal equations. Let's take a look at level 1 first. When solving a literal equation, the most important thing is to identify which letter you're solving for. In this case, we're solving for capital A. So to isolate the letter A, we need to remove dividing by 5. The inverse of dividing by 5 is multiplying by 5. We're going to multiply every term on both sides. And now the A is isolated. The A was already isolated in this answer box, so I simply have to write 5G here. In this example, we're solving for uppercase B. So we're going to add 4 to both sides. And if you have unlike terms and you can't compute the math, you leave the math side by side like this. Be sure to type the right case for each letter. If it's capital, write a capital. In this case, we're going to add F to both sides. And again, on the right-hand side, if you cannot add N plus F, you simply write it side by side like this. In this problem here, we want to solve for lowercase g. So we're going to do the inverse of multiplying by n, which is dividing both sides by capital N. So when we type our response, we're going to type a Q, a division sign, and then we'll be able to get our letter N down there. All right, let's take a look at the next topic. Level 2. Identify the variable you're trying to isolate and compute using inverse operations. In this one, g is being multiplied by this entire quantity. So we can divide by that entire quantity in one move. Just like this. When you're typing your response, you can type that entire denominator as a single group. Oops. Make sure you use the right case for each letter. Lowercase n, uppercase h. In this problem, we're solving for lowercase b. So b is part of a fraction right now, and to eliminate this denominator, which is dividing, I'm going to multiply both sides by the entire expression that's in the denominator. Just like that. So now my solution is that lowercase b is equal to the quantity d plus 2 squared times g. One more time. We're solving for lowercase a. In this case, lowercase a is being multiplied by 3 and r at the same time. So I'm going to divide by 3r at the same time. So my solution is that lowercase a is equal to d squared plus 4, all in the numerator, and 3r in the denominator. All right, let's take a look at the third topic, which is similar to the last two, but the formulas represent a situation. So we can read the entire formula here, or we can focus solely on what variable we want to isolate. So for this problem, we want to get b sub 1 by itself. So b sub 1 is what I want to remain alone. In this original formula, it was being added to b plus 2, plus it's being multiplied by 1/2 and h. So the first thing I'm going to do is remove the math outside of these parentheses. So to remove a fraction, I multiply by its reciprocal. So I'm going to multiply both sides by 2. When I do that, the fraction will disappear. Leaving me with h times the quantity b1 plus b2. Next is to remove what's outside of the parentheses. So we're going to divide by h. Since nothing is multiplying the quantity anymore, I can erase these parentheses. And now I can isolate b sub 1. And I do that by subtracting b sub 2. The final answer is the fraction 2a divided by h minus b sub 2. And that's what we'll type in our answer field. We're going to use one of these keys down here to type b sub 2. In this Celsius formula, we want to isolate or solve for the letter f. Again, in order to solve for f, I need to remove all of the math that's outside of the parentheses. To get rid of a fraction, you multiply by the reciprocal. Because I'm no longer multiplying this quantity by any item, I'm removing the parentheses. I'm going to add 32 to both sides to isolate f. 9/5 c plus 32. Last one. This formula looks pretty complicated, but don't be intimidated. You're just using inverse operations to solve for L. So first thing is notice this is a grouping symbol. Remove all of the math outside of the grouping symbol. So we're going to divide by 2 pi on both sides. And now I can remove this grouping symbol. The inverse of square rooting is squaring. What you do to one side, you'll also do to the other. Now this square root and this square will cancel each other out, leaving the left side as L divided by G. Leaving the right side as L divided by G. But the left side, I do not want to compute. I'll just leave it as a quantity squared. Now to get L alone, I simply multiply both sides by the denominator of G. And now the L is isolated. And I'm going to multiply G times this giant fraction that's being squared. You can use some of these buttons down here to fill in some of the characters, as well as using Shift 6 to write the square. Let's take a look at the next section. Linear inequalities. This is like solving an equation, except sometimes the inequality symbol reverses order. That means it might begin as a greater than or equal to sign, but it might end as a less than or equal to sign. And that happens when you multiply or divide by a negative number. Let's take a look at our first question here. I'm going to add 3q to both sides. And now I'm going to subtract 9. In my final step, I'm going to divide by the coefficient. but the number I'm dividing by is positive. Therefore, my inequality will remain the same. It does not change directions. And I can leave my answer in fraction form. So from the drop-down menu over here, we're going to choose greater than or equal to, and then in the answer box, we'll type our fraction. Let's try one more. I'm going to subtract 10c from both sides, leaving me with negative 9c minus 8 is less than 3. I'm going to add 8 to both sides, giving me negative 9c is less than 11. Now this time, when I divide, my coefficient is negative. That means that my inequality symbol is going to change directions. So c is greater than 11 over negative 9. So we're going to choose from this drop-down menu and then type our fraction in the box. All right, let's take a look at the next section. Number lines and inequality notation. In this example, a number line is shown, and we have arrows pointing in different directions. We also have endpoints that are solid circles. There are two kinds of endpoints, solid and open. Solid means that you can be equal to or greater than, or equal to or less than. These symbols contain an equal sign. The open endpoint refers to the inequalities that do not have an equal to sign in them. So you'll notice here in our example that we have two closed circles. So we're dealing with these two symbols. This one says I can be anything that is less than or equal to negative 10. The number I'm thinking of is less than or equal to negative 10. And over here, the number I'm thinking of is greater than or equal to 1. Let me erase this so you can see the number line a little bit better. Now I have two inequalities here, and they're going in opposite directions. So that means I have something known as an OR. I can either be less than negative 10, or I can be greater than positive 1. So I can use these symbols here, but I could also use these inequality notations here. Now when you point for forever in one direction, that's known as an infinite direction. And if it's pointing to the left, it's negative. If it's pointing to the right, it's positive. So I can state here that I am between negative infinity and negative 10 with a hard-sided bracket, or, outside, or I can be equal to 1 all the way up to infinity. Now remember, you cannot be equal to infinity, so that's why each of my symbols here have a parenthesis. Now, because the question is asking us to write it in inequality notation, I can't use these symbols. So I'm going to go back and I'm going to state, using these inequality signs, that my number x can be less than or equal to negative 10, or my number x can be greater than or equal to positive 1. This is inequality notation. Notice the difference. Let's try another one. This one has a number line. It wants me to graph both of these statements. Now be careful how to use this number line, because you're going to click your finger and hold it down until you see what you want to appear. Then you can click this little red circle to take away anything you don't like. So x can be any number that's less than or equal to -7. So I'm going to go to -7. I'm going to click my finger on the mouse and I'm going to hold it. Then I'm going to move my finger to the left until I reach the arrow, because I can be any number as long as it's less than -7. This has an equal to sign, so my endpoint should be solid. You can change it from solid to open by clicking it. The second statement is that I can be greater than or equal to +8. So click on +8, hold your finger down, and move your finger to the right until you see an arrow. Again, it has an equal to sign, so my circle should be solid. Now they want me to read this symbol here using inequality notation. It looks like I cannot be equal to 3, I cannot be equal to 6, but I can be any number in between them. In interval notation, we write that using 2 parentheses, with 3 as my lowest and 6 as my highest. That's interval notation. With inequality notation, we state the lowest number, 3, and then we state 2 less than signs with an x in the middle. In order for us to say I am between these two numbers, the x has to be in between the 2 less than signs. Now I'm not using less than or equal to because the circles are open. If this circle was shaded in, I would use one of these symbols. One more time. Express the interval shown on the number line in inequality notation. So inequality notation uses these inequality symbols here. Looks like I can be anything that's less than 8. So x can be anything that's less than or equal to 8. The circle is solid, so I use the equal to sign. Now let's plot this on the number line. I can be any number that's less than or equal to -3. I go to -3, I click and hold, and drag my finger to the left until I see an arrow. This circle should be solid because the symbol has an equal to sign. Now the other one says I can be anything greater than or equal to 7. Click on 7 and hold till I see the arrow. One more time. X can be any number less than 4. Go to 4, click once, drag until I see the arrow. Now I'm going to click on the 4 to open the circle. The second inequality states I can be greater than 10. Click the 10, hold my finger down, and drag to the right. Go back to 10 and open the circle. For this next equation, it says to use inequality notation, but I'm going to use interval notation so that you can get some practice with both. It looks like I can be any number that's in between 0 and 10. The 0 is solid. The 10 is solid. So that means I need 2 brackets. Interval notation starts the beginning number and the ending number from least to greatest. These symbols are chosen depending on the type of circle. So I could type here in this box, this button here, with a 0, a comma, and a 10. I could submit this and it will give me full credit. The other notation I can use is inequality notation. That states that I can be between 0 and 10. So I start with 0, I write the less than or equal to sign, I write the x, I write the less than or equal to sign, and I write the 10. Both of these answers are correct. Let's take a look at the next section. Number lines and interval notation. So in this case, I'm between 0 and 2. Both of the circles are solid, so we're going to click these 2 brackets. the smallest number is 0. After the comma, the biggest number is 2. And we're done. In this one here, I'm between -4 and 6. Both circles are solid, so I choose 2 brackets. -4 is the least, after the comma is the greatest. In this example, they use a funny looking symbol. It stands for the union, or the combination of. The union, or the combination of. I can be anything from negative infinity to -4. So from negative infinity to -4 looks like this. Now you'll notice it has a parentheses, so that means the 4 is an open circle. The other part is that I can be from 5 to positive infinity. So 5 to positive infinity. Again, 5 has a parens. That means the circle should be open. And this means the union of the two. Last one. Looks like I can be any number that's less than -3. Now because this circle is open, I need 2 parens, negative infinity to -3. Since there's another segment, I'm going to use this intersection symbol. Positive 10 to infinity. The 10 is a circle that's open, so I need 2 parens, 10 and then positive infinity. That concludes homework number 7.